We are looking at a problem set. Next one is two tankers contain 850 liters and 680 liters of petrol respectively. So we need to then find max capacity of a container, max capacity of a container which can measure petrol of either tanker in exact number of times. So solution, let's understand this first. We need, what they are asking, we need a container which can measure petrol of either tanker. What did this means? It is saying a word measure. So let's do this. Let's take an example of a big square. And we started filling this square by unit squares. So let's fill this first. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So we needed 30 unit squares to fill this big square. So 30 unit squares becomes a measurable value or measure for this big square. So this is what measure means. Now they are next asking capacity of a tanker, and that should be exact number of times. Two things are there. So if a container measures tanker perfectly without leaving any petrol, a drop of petrol without leaving any petrol behind, its capacity must divide. So if a container measures tanker perfectly without leaving a petrol behind, its capacity, so the tanker which we are going to calculate means its capacity must divide the tanker's capacity, tanker's total capacity perfectly, means that remainder should be 0. Perfectly means remainder should be 0. That means here we are talking about the concept of factor. We are looking at a factor. And also this tanker's capacity should be common for 850 liter of tanker and 680 liters of tanker. So next term comes as common. Now also we need to find out max capacity. So that is highest, we can say highest capacity. So again a term comes highest. So as we can observe, we need to find out highest common factor HCF to calculate or to get capacity of that tanker which divides perfectly to the tankers of capacity 850 and 680 liters. So we need to calculate HCF. So let's go ahead with that. So let's find out HCF by prime factorization. So first is 680 and we are going to divide by 2. 340, 2s are 680, then 2170 into 2 340s, then 285, 2s are 170s, then 17 5s are 85. And here 850. So 850 2 divided by 850 divided by 2, 4 to 5. Then we use 5, 85, and then again 17 5s are 85. So here we get 680 as product of 2 into 2 into 2, means it is a prime factorization product. 2 into 5 into 17, that is 2 are 3 times, into 5 is 1 time, and 17 is 1 time. And for 850 we get 2 into 5 into 5 into 17, that is 2 1 time, 5 2 times into 70. So we have to get common factors that are 2 5, we'll underline that, 2, 5 and 70. So 2, 5 and 17, these are the common factors, but how many times, that also depends. So minimum one time 2 occurs in a F850, minimum one time 5 occurs in 680, and in both minimum one time 17 occurs. So we will consider minimum times. Therefore HCF is product of 2 into 5 into 17. One time, we are taking just for one time, so it's a 170. So 170 liter of container can measure petrol of either tankers in exact number of times.